Good afternoon to you from the Johnson Space Center. Welcome to today's STS-133 mission status briefing. We are joined by Brian Lunny, the lead shuttle flight director. He just wrapped up his Orbit 1 shift for this mission. Also the last on-console duty for his entire career. We're not quite done with him yet, so he's going to give us an update with 133 today. We're also joined by Kenny Todd, the Mission Integrations and Operations Manager for the International Space Station. So we'll talk about today's undocking activities. We'll get started with Brian.
Thank you, sir. Thanks to all of you for coming out. We've had another great day in space, so while it was my last shift, it was certainly a great shift going out on top. Everything's in great shape. Crew woke up this morning, flight day 12. They woke up about 2:23 Central Time. We performed our undock and fly around as scheduled at about 6 a.m. They began their late inspection, which is where we're going to go get the OBSS and use our robotic arm to inspect the TPS on the vehicle, make sure it's in great shape for entry. The berthing of that, the OBSS, will occur about 3:30 this afternoon when they're done. And then the folks on the ground, the damage assessment teams, will go through all the data from the inspections and review and make sure the orbiter is still in great shape for landing. And we should have those results sometime tomorrow or the next day, and I think Tony Sakachi or Leroy Kane will bring those results to you. Tonight the crew goes to sleep about 6:23, and again they wake up tomorrow about the same time at 2:23. And that will, on flight day 3, of course, 13, kick off the nominal into mission -1 day activities, FCS checkout, RCS hot fire, and those sorts of things. We also have a couple of Rambo burns scheduled, which are called RAM burn observations. It's a little DTO we do where we burn the RCS engines, and a couple of times, one in the morning and one in the evening. The undock and fly around, as I said, was nominal. Eric Bowe did a fantastic job flying the profile. There were no issues whatsoever. The team was there to support them, but he did it all on his own from what I could tell. He did a great job, right on the profile, exactly as we would want. We looked at some of the early propellant consumption numbers, and he came in a little bit low, which is great. That means he used less than expected. He just flew a really good profile. At the end of that, we did our SEP2, which was a 3 foot per second retrograde burn, and that's setting us up for an orbit adjust later on tomorrow. That will set up some deorbit opportunities that entry flight director Tony Sakachi will be in here tomorrow to talk with y'all about. Again, the late inspection ops are ongoing. Steve Lindsay, Eric Bowe, and Al Drew are flying the arm, taking a good close look at the TPS, making sure it's in good shape, and they're going to downlink all of that data for the folks to review on the ground overnight, and things are going to look really good. From a systems perspective, Discovery's in great shape, as I mentioned. Really don't have much to say, talk about, because there are no real anomalies to talk about. She's just doing great. So we're optimistic everything's going to continue for the next couple of days as they have for the past couple of weeks. And that's about all I got.
Well, thanks very much. It's great to be here with you today. We just concluded an absolutely fantastic dock mission with the shuttle team. You know, every one of these missions, when you go into them, they tend to take on their own character, as defined by what problems you deal with along the way, whether it's on the shuttle side or whether it's on the station side, or, you know, if we have an issue with an EVA and we end up having to go back and remove some objectives or rework the plan a little bit. And this mission was no different. We had some bumps along the way, but nothing that really threatened us from having to change the mission profile or anything that we wanted to do relative to the objectives we accomplished. So I think if I had to step back and characterize this entire mission, I would really call it an above and beyond mission. The systems performed very, very well, well to the point that we were able to add a couple extra days, which we just don't do that often. We don't do dock missions and add a couple extra days, but it allowed us to go and do some work on the PMM, accelerate some of the outfitting, which really helps to preserve some of our science opportunities in the stage, since we've got a lot of traffic coming to and from station over the next several weeks. So being able to get that work behind us now with a larger crew was very, very helpful for us. In addition to that, we had an opportunity to perform some repair tasks that again we'd have had to do in the stage. One that we've been tracking, another one that came up early in the mission with the cedar, the carbon dioxide removal assembly, and we went and did that task as part of the extra days. In addition to that, again, keeping with the above and beyond sort of mission we had, even in the EVA, we were able, with this particular crew, to go out and get several what we call get-aheads, things that we had been tracking that we wanted to get accomplished during the mission, but they weren't in the original timeline. But the performance of the crew actually allowed us to go get those added, so that was outstanding. Again, following the same theme, the shuttle left us in a great shape. The shuttle performed so well that we were able to get some extra consumables from them in terms of O2. They didn't use near as much LiO as they thought they were going to use, and so I think that's all just a testament to the team at KSC that prepares this vehicle and gets it ready to fly. It's obvious by the performance that they put their heart and soul in getting this vehicle ready to fly for us, and as the primary benefactor of it here in the ISS program, we can't say enough about the job that those folks have done for us. So definitely bittersweet this morning as a space station program person to see Discovery leave. She had done just a flawless mission for us in support of the program, and yet as she was backing away, it was clear to us that was the last time she was going to visit us. So again, bittersweet, and so we bid her adieu, and certainly Godspeed to Steve and the rest of the crew on the way home. Going forward, we've got just a busy time in front of us. We're going to go relocate the HTV later this week. Next week, we're going to be bringing home 24S, which will have Sasha and Oleg and Scott, which will leave behind Katie and Paolo and Dimitri. Following that, about 12, 13 days later, we're going to unberth the HTV and deorbit it. So, and then we'll start setting up for our going back to 6 crew with the arrival of 26S, which will be Ron and Andre and Alexander for their 6-month stay. Then shortly after they get their space legs, around the 19th of April, we'll be looking to welcome our shuttle friends again and Endeavour. So there's a lot to be doing over the next few weeks. So getting this work behind us, as we did, really sets us up in a good position going forward and being ready to accommodate all the vehicle traffic that's right in front of us. We're going to give the crew a couple of days off and let them catch a breath, and then we'll be hard back at it next week or later this week. And you know, it's an honor for me to be up here today, just as a last statement, to be here with Brian. For those of you keeping the stats, he did over 300 shifts as an ISS flight director. So his legacy in our program is definitely secure, and we're certainly going to miss him. So anyway, with that, I'll be open to any questions you have.
Okay, let's start off with the questions from here at JSC. Who wants to go first? Gina.
I've got a simple question for both of you, Brian and then Kenny. Tell me each what you think the legacy of Discovery will be.
Okay. I think of it as a legacy of the whole program, not just one vehicle. For me, I worked 50 some odd shuttle flights. They're pretty equally split across them. And I worked with all the vehicles. And to me, the shuttle program is just evolution of the tool the space shuttle is. If you think back to 1981, April 12th, when we launched Columbia, years before that were a huge challenge for the folks who were up here. You know, my dad was here, and many of his colleagues were struggling with a lot of the technological challenges at the time of, gosh, how do we make this thing fly safely, successfully? If you remember back in the day of trying to get the Columbia off the ground, they had real-time software challenges, getting the PASS and the BFS to talk to each other. They had the challenges of the solid rocket boosters, the SRBs, the external tank, and all of the orbiter systems, all working together to achieve the mission they wanted to achieve. So when John Young and Bob Crippen climbed on board that vehicle on STS-1, they were some pretty amazing guys, because at the time, of course, we'd never flown a space shuttle. Of course, we did approach and land tests, which was we dropped it off the 747, but we never launched the rocket as an integrated vehicle. So STS-1 was an amazing feat in and of itself. Of course, that was a different vehicle, but it was an amazing challenge that they overcame all the engineering challenges associated with at the time. And then I think back how we evolved the tool. I think of it as a tool. It's a piece of hardware and some software, of course, but to me it's a tool that we evolved it, and we being the collective engineers and ops guys and managers guys here on the ground who evolved it to do some amazing things. Initially we were flying up there We were doing 5-day missions. We'd deploy a satellite on flight day 1. We'd kind of sit around for a few days, and the crew would deorbit and come home. And wow, those were really tough missions at the time. You know, today we look back and go, God, that was a piece of cake. But as we went by, the mission complexity got greater and greater. We added a couple of payloads. We deployed the little getaway specials and other little things, all kinds of deployables. We retrieved things and brought them back. I remember one of my first missions coming back when I got out of college here was the LDEF, the retrieval of that, and going through all the propellant numbers and, oh, we're going to have enough propellant to rendezvous with this thing, what orbit's going to be at. And they got some great science out of that. And then we evolved to longer missions with the space HABs and the space HABs. So again, the guys on the ground, the managers, the engineers, the folks at KSC taking care of the vehicle, and it really is all those folks across the country and all the teams associated with the vehicle. Orbiter systems were scattered across the country, and the engineers at all these different places, you know, for their little piece, they would be refining it, making it better. So on one flight, we'd have a little problem with a particular component, and they would evolve it, and it would take a couple of years usually to, okay, we need to try this, test it on the ground, test it on the ground, but eventually get it better. And that's, I think, part of the reason why Discovery today is in such great shape, because we evolved many of the systems and things on board that vehicle, so we know how to operate them. We evolved how we manage the vehicle at KSC, and those guys do a great job because they have so much history on how to take care of that vehicle. So again, it's the evolution and the ingenuity of that tool. So mission complexity got more. So eventually we're flying up the space station Mir, joining with our friends over in Russia, which was a huge leap in the 90s, as those of us who were there all remember. And then, of course, building the International Space Station, which Kenny is taking care of for us right now. But the International Space Station today, you know, 900,000 plus pounds. I was getting the number from Josh, but it's big. It's simply big. There's a lot of hardware up there. And the shuttle brought a big chunk of that up there. Inside volume, better than five-bedroom house. Wingspan, bigger than a 747. Arguably, you could say the space station is the shuttle legacy because of all the things that we brought up there to assemble that space station. And station is going to continue the good science it's doing today, and hopefully for another 20 years, however long we can keep it flying. We should, because we spent a lot of time getting all that stuff up there. Using the tool that is known as the space shuttle, the folks on the ground have evolved that and made it better and better so that it could go fly to space station. And the other point about that is, if you'll remember, getting to space station was going to be a difficult thing. We switched from a 28.5 degree inclination to a 51 degrees inclination, which, okay, it doesn't mean a lot to most people, but for us rocket guys, it means I need a lot more performance. And we went and made the external tank lighter. We made other improvements to the vehicle so we could enable that to happen. So over those 3 decades, generations of people have evolved this vehicle to be able to do some amazing things. And I think we're going to look back at it and just go, wow, it's just unparalleled in the history of mankind what we've been able to do with that shuttle.
Well,
Come back to follow. Go for it.
as far as the space station program, looking at it with my space station program hat on, I look at Discovery and looking at the flights she flew to see us, and I think when you look at over half the flights, they were either MPLM flights or Space HAB flights. And when I look at those flights, I kind of get this mental image of, here comes the care package. Because if you look at all these different elements, and Discovery brought up a couple elements, you brought up Node 2 and I think the GEM, but when you look at by and large, the cargo that it brought to us, it was a lot of outfitting cargo. It was a lot of things to get space station in a configuration where we have the robustness that we have today, where little things that happened on this mission that used to bring us to our knees or cause us to go question whether or not we wanted to stay with the same set of mission objectives. Now we're able to step back and say, you know, we'll deal with that in time. We got robustness. So I look at Discovery and what she did for us, and the number of flights that she brought these care packages for us, and said, you know, that was well done. That's what we needed. You know, care packages are those things that hit the spot when you need it, and that's what she did for us.
Robert.
Hi, Robert Promo with CollectSpace.com. Just to follow up quickly on something you said, Brian, the weight of the station now is, or maybe this is for Kenny, the weight of the station now is what, and what is how do we describe how complete it is? What percentage complete is it?
I'll let you take that one. It's big.
He's right. It's a little over 900,000 pounds right now. If you look strictly at the USOS capability in terms of volume, we've essentially completed what we have today in terms of our plans for the USOS. It's 100% from a volume perspective. We've still got some mass to get there in terms of the AMS payload that we're going to take up carrier, the external logistics carrier that we're going to take up ELC number 3, and that will be brought up on ULF 6. So we're getting close on the mass, but the volume we still have the Russian MLM module. If you want to talk about the overall habitability and the volume requirement, we still have some work left to do, waiting on the MLM to get there. But USOS wise, there's nothing else in our plan that gives us additional volume that we're working to right now.
And for Brian, if to sort of follow up on Gina's question and to sort of turn it in on yourself, since this is your last shift, last day, what would you say was the legacy of Onyx flight for the shuttle program?
Gosh, I don't know. Hopefully I was able to. Onyx flight is my flight director team color, for those who don't know. Named somewhat after my father's team, who was black flight. So I wanted to stick with the family tradition to some extent there. I came into this program to hopefully make this a better place, this world a better place for my kids. I think what we do here at NASA does that, help, getting them along in their way.
Mark?
Thanks, Mark Carreau for Aviation Week. And I just wondered if the oxygen generator assembly went through its entire checked out and came through that okay.
We've done the mods. What we set out to do was do a remediation of the loops and recover the pH to a level that we feel like it's safe to run the equipment. At this point, we haven't actually turned the system on to run it, but it's processed. It went through the remediation cycle just fine. But that's something over the next couple of weeks we'll put together a plan for how we want to phase that operation with all the other consumables that we have on board right now, with the other tanks that we have in play that we need to use the O2 from them as well.
Thanks. And as far as Discovery, at this point, how long can it stay on orbit? What consumables are limiting its stay?
We did donate a lot of oxygen to our friends on the International Space Station. We have about, I think it was 40 pounds or 4 hours worth of margin over our nominal +2. So Friday is when we need to be on the ground. And Tony Sacacci, of course, will be here tomorrow to share all that with you. And I fully trust Tony to get down on the first opportunity at KSC on Wednesday. And you can offer that as a challenge to him, I guess. But Fridays, we need to be down by Friday.
Okay. Denise, do you have anything? Okay, over here. Okay, let's go down to the Kennedy Space Center and see if there's questions there.
Hello, Marcia Dunn with the Associated Press with a couple questions for you, Brian. I'm just wondering how much longer could conceivably the shuttles keep flying if there were no politics involved, no anything else except the machines?
Well, that's, in my opinion, like I said before, we've evolved how we fly it, how we operate it, how we maintain it, all the components on it, and as you can see from this mission, Discovery's in great shape. If we made the choice to continue to manufacture external tanks and keep the solid rocket boosters full, you could keep flying it for a long time. I don't know what the exact duration. I know the CABE report said we need to recertify it, but in effect, we sort of do that every time we fly because the folks at KSC go and scrub it down and make sure it's in great shape. If I was going to continue to fly it, there's a few upgrades I'd probably want to do to some of the avionics boxes. But all in all, the vehicles continue to be in great shape, and we could keep flying it for some time.
And I'm wondering, presumably you're leaving because the shuttle program's ending, and I'm just wondering whether you anticipate an exodus of people like yourselves, a lot of smart people leaving NASA, and whether you have any concerns about that at all?
Well, smart people, is that for me? Thank you, Marcia. Let's see. Am I worried about that? Sure. We've been addressing that since we've known the end of the shuttle program was coming. We've been working on maintaining and ensuring we have folks to support in all the different elements. And it's all the way across the country, all the different engineering teams and contractor teams that support the Space Shuttle program. We've been working with them to ensure that they had the number of bodies, the right number of bodies, the right bodies to support. And we believe we've done a good job at that. We got 2 more flights to go, and I think we're going to be fine getting to that milestone with the support that we have.
And lastly, to put you on the spot one more time, when is your last day at NASA, and do you mind sharing where you're headed?
My last day is going to be sometime this month. I actually haven't picked it. It'll be a couple of 3 weeks away. I've got a very unique opportunity called Odyssey Space Research and another company called Firestar Technologies. And I'm really excited to go work in that business. It's going to be very different, obviously, from what I do today. But it's a unique opportunity I just really couldn't turn down. I did want to stay around for the last 2 shuttle flights, but the timing of things just did not work out for that.
Okay, thanks, Marshall. Let's go to the phone lines. I believe we have Todd Halverson.
Yeah, Todd Halverson of Florida today. Can you hear me?
We can. Go ahead, Todd.
Oh, great. Brian, I want to follow up on something you said yesterday. You were talking about how problem-free this flight has been for Discovery, and I'm wondering if you picked up any IFAs during the course of this flight, and if not, how unique it is for a shuttle to perform this problem-free, and what that says about the fleet as it's heading into retirement.
Okay. See, as far as IFAs or anomalies we may have experienced, the shuttle, like I said, the orbiter systems are all doing perfect. You may have heard the humidity separator collect a little bit of water, but that's frankly nothing too unusual, and we were able to deal with that just fine. That was on flight day 1 or 2, I think it was. But the vehicle itself is in great shape, and yeah, that is a testament to how we take care of them. So I don't know of any, there are no other anomalies with the vehicle. It's in great shape. I think I missed the second part of your question, though.
I think that covered most of it. I just wanted, I know C5 is going to be over here tomorrow.
Yep.
Could you, however, give us an early hack on the weather and what it looks like on Wednesday? Thanks.
You know, I chuckled at one of my reporter buddies in the room yesterday when they asked me that question. You know, as an NASA entry flight director, folks would ask me a week out, how's the weather look? I'd say, I don't know, I haven't looked. And that was an honest answer, because it's that Florida weather. It's always a challenge. So we wait till we get in close, and we keep looking at it, and Tony's going to do that, and his entire team's going to do that. The early forecast, though, is favorable for a Wednesday landing, so I'm optimistic things will work out for him.
Thanks, that's all from me.
Okay, Todd, thank you. Bill Harwood. I think we may have lost Bill. Let's go to Charles Atkinson. Are you there?
Yes, can you hear me okay?
We can. Go ahead.
Charles Atkinson with SpaceLaunchNews.com, Examiner.com. Kenny, looking ahead from a resupply standpoint, why would you fly STS-135 so close to 134 2 months out when you could maybe launch it a month later so for resupply?
Well, when you look at what we're looking at launching on that particular vehicle, we've got some additional food we're going to launch. We have spares for the regenerative eclipse system, consumables for the waste and hygiene compartment. So a lot of the things that we're going to fly really push us out to the end of the year on into well into next year. And so whether you fly that flight in June versus flying it in August or September doesn't hurt us from a resupply and a consumable standpoint. We've been targeting for some time to have this flight in June, so we've been stressing to all of the hardware providers who have to deliver the hardware for flight that we need to be prepared to go fly in June. So if that's ultimately where the shuttle program needs us to be ready to fly, we've been working that way. So I don't know that it really affects us that much from an overall hardware delivery standpoint and what our needs are on orbit. A lot of what we're talking about on this vehicle are things that are going to push us out again into next year, and so that was the original target for the manifest was to load those types of consumables on, and that's what we're able to do, and we can do that if that's when we need to fly, is in June.
Okay, and touching on that, is there any large hardware that 135 has to fly that won't go on Progress or cannot?
Well, let's see. There's a hydrogen dome that is part of the regenerative ECLS system that right now, if we can get that guy on 134, we're looking at that. It's in our trade space to go look at that. I'm not sure how easy it would be to fly that on a Progress. We'd have to go work with our Russian colleagues. That's the biggest piece of hardware that I can think of that have to go try to deal with. But again, right now our primary option for that one would be to try to fly it most likely on 134.
Okay, thank you. And one last one for Brian. Tomorrow at noon Eastern, Discovery's crew is going to hold a tribute for Discovery. What do you expect, or do you have any inside word on what to expect during the tribute event?
I don't really have any insight. I did talk briefly or listen in on the conversations they had. I know the crew's just going to talk about Discovery and how wonderful the spaceship she has been for them and for previous crews. And I expect it'll be a very nice tribute that they will perform for us tomorrow.
Thank you.
All right, thanks, Charles. We've got Irene Klotz as well. Go ahead, Irene.
Thanks very much. My question's for Brian. In your new role, are you expecting to be working at all with any of the commercial companies that may be taking over some of the human spaceflight operations? And then on a general sense, just what do you think the prospects are for commercial operators to fly astronauts to and from the station? Thanks.
Oh, goodness. In my new role, yes, it's possible I would be working with those folks on various different things, and I know that Odyssey has relationships with most of those, actually, customers. And as far as the new role, all I can say is that from having done this for the past 22 years, I know how darn hard it is that everything actually has to go per mission on your systems, on your vehicle, in order to successfully take a crew to space and back. It is a huge challenge, and it's a world we're stepping into. So we learned a lot of lessons early in the space shuttle program, early in every other space program, and some of those lessons were hard. And we're going to have those same sorts of lessons possibly. Each of those guys who goes and tries this is going to have some challenging lessons that hopefully they'll overcome easier than some of the lessons we learned.
Thanks very much. And also, just on a related note, for Kenny, is there any word yet if SpaceX is going to be able to combine their next two COTS demos and dock at station on the next flight? Thanks.
Sure, hasn't been made yet. I believe that'll be in weeks to months type of decision. So we'll let that sort of draw to its conclusion at the headquarters level.
Thanks very much.
All right, thanks, Irene. Let's come back here to Houston, see if there's any more follow-ups here. Are there? Okay, we'll wrap up today's briefing. The crew is in the middle of their late inspection on board Discovery, so we're going to send it back to Mission Control, but we want to remind you that the wake-up call is coming at 2:23 a.m. Central Time. This will be the second of the two wake-up song contest winners. We invite you, of course, to pay attention to that. We had a little surprise this morning with William Shatner. There may be a surprise or two in the morning as well, so pay attention to that. Let's go back to Mission Control for more continuing coverage of STS 133. Thanks.